right, today we will be doing lesson dash or 5-5 inequalities in two triangles. So this is actually going to be the last lesson of the chapter. So what you'll do is we'll cover these notes. You'll do some practice that goes over 5-4 and 5-5, and then we will review, and then you will be tested on this chapter. So we are looking at inequalities in two triangles, and you see a couple paragraphs here. So generally when we see a paragraph in math, it's kind of a bad sign, but we're just going to kind of use this theorem in a pretty simple way. So I will read this theorem. It's kind of long, a little bit wordy, and then I'll explain in a pretty simple way what it is. So it's called the hinge theorem. And this theorem is saying that if two sides of a triangle are congruent to two sides of another triangle, and the included angle, the angle right here, of the first is larger than the included angle of the second, okay, then the side opposite the angle of the first triangle is larger than the side opposite the angle of the second triangle. Okay, so a lot of words to basically say. If I have two triangles and they have two congruent sides, and I tell you that the angle that's in between those sides is bigger than the angle of the other triangle, then that means that the side would also be bigger, because we know from the last lesson that the biggest angle is across from the biggest side. So if we're saying that this angle is bigger than this angle, then that means that this side would be bigger than that side. Okay, that's all that's saying. So this is the hinge theorem. So in symbolic form, I'm going to write this as well. So if we're saying if the measure of angle A is larger than the measure of angle D, then that means that BC, so the segment across from it, is greater than EF. Okay, so that's the hinge theorem. And then the converse of the hinge theorem is just saying that backwards. So now basically, if I say that, instead of reading all of this, it's kind of a lot, it's basically saying if I say that BC, so if I say the segment across from the angle is bigger than the segment in the other triangle, then that means that the angle must be bigger as well. So if I say that BC is greater than EF, so literally just backwards, then that must mean that the measure of angle A is bigger than the measure of angle D. Okay, and that's the hinge theorem. So we just want to know that theorem, and then we're going to apply it by comparing the sides and angles down here with some examples. So basically, we are just going to say how these side lengths compare to each other. So, for example, on number 1. So what it's saying here is that you have these two sides that are the same, okay? And then you have the included angle, so the angle between them. So in this one, we're saying that 79 degrees obviously is bigger than 74 degrees. So that would mean that this side that's across from 79 is bigger than this side that's across from 74. Okay, and probably seems a little bit like common sense. So this angle is bigger, this side is bigger. So we would simply write that KL is greater than PM. And that's it. And we're actually just going to be kind of just comparing these side lengths and angles throughout. So let's look at number 2. So it says we're going to compare AD, so this one right here, with BC. So we basically want to look at the angle that is across from it. So like this one, you have 59 degrees. Across from it, that's AD, and then you have 65 degrees. Across from it is BC. So which one would be bigger? The one that's across from 65. So BC would be bigger. Okay. All right, let's look at number 3. So we're looking at WX and XY. So I'm going to look at WX. So WX is across from angle here, that's 53 degrees. And then XY is across from this angle here. Okay, well, what is the measure of that angle? Now I got to do a little extra work. So how can I figure that out? Well, they gave me 32 and 93, so I can simply do 180 minus 93 minus 32. So sometimes they make us work a little bit extra to figure that out. So when I do that math, I am going to get 55 degrees, meaning this guy right here is 55 degrees. Zoom in a little bit. So that says 55 degrees. So now, okay, what's bigger, 55 or 53? 55 is bigger, so XY would then be larger. All right, let's look at another one. So number 4, we have, we're comparing PQ. So we're comparing this one right here to PS. So we know that PS is 83 degrees. However, we do not know what that angle is. So we're going to have to figure it out. So I know that those two form a straight line. So I can figure that angle out by doing some subtraction. And I can simply subtract 83 from 180. So that angle would be 97 degrees. So which one would be bigger, this one or this one? We would say PQ because it's across from the larger angle. All right, now we have number 5 here. So angle D and angle H. So we're just going to look at the sides or the angles that are across from the side. So now they're given the sides, we got to do the angles. So angle H is right across from 33 and angle D is right across from 35. So which one would be bigger? Angle D. All right, now number 6. So angle A and angle E. So let's look at the side across from. So angle A is across from 16. Angle E is across from 15. So what's bigger? Angle A. And when you think about this, like, yes, this is easy because you know exactly what to do. You have to remember this theorem. So if you're given this problem on a test, say it's the EOC, you have to remember that, okay, I know that the side across from the angle is the biggest, or excuse me, the side across from the largest angle is the largest side. Okay, so that these have a comparable relationship. Otherwise, you won't know how to do the problem on a test. So it's about remembering, the hinge theorem and what it means for angles and sides and their relationship. So number 7, RSQ, looking at this angle right here. So this one, it is across from 13, and then TQS is across from 14. So which one is bigger? TQS. And last one, JMK. So we're looking at this angle right here, which is across from 27. And then LMK, which is across from 28. So which one would be bigger? The one across from 28. And that is it. That is the hinge theorem.